Okay, good afternoon. This is this session when you sleep after lunch, right?
Yes.
Yeah. How many of you had enough to eat that you're going to likely fall asleep? I'm impressed it's not everyone. So welcome back after lunch to talk about these trivial topics that you might as well just sleep through, like backups, or in this case, Postgres backups, the modern way. My name is Magnus Hagander. For those of you who didn't see my intro in my talk yesterday, I work for a company called Red Pill Info, which is an open source services business in the Scandinavian region. I'm based out of Stockholm in Sweden myself, and we do all sorts of open source services and supports and trainings and things where I mainly do, well, Postgres, which is why I'm here, obviously. Within Postgres, I'm also a member of the core team. I'm one of the committers, and I also do a lot of work for Postgres Europe, such as running the European version of events like this. So, enough about me, more about backups. I'm sure everyone knows what a backup is. I hope you do. And I'm sure you all make them, right? Who in here makes regular backups of your production systems? Okay, that's good. Who in here restored one of those backups, let's say in the last month? Okay, so there's some of you that actually have backups. That's good. Those of you who haven't done that, you should really try that. Now, hopefully for those of you that did it, you didn't do it because you had a major disaster. You just did it to prove that you could do it. But it's actually surprising how often these days, as a consultant going out to different customers, you run into people, they don't have backups. And you hear things like, well, we have replication. We don't really need to do backups because, our replication will take care of that. That's not really how it works, right? We normally always have issues with, replication is too slow. We have lots of replication lag and all that stuff, except when you drop the wrong table, right? That replicates instantly. There's never any chance to stop that before it's too late, right? I've heard others saying we're running in the cloud, so we don't need backups. Like, you possibly need backups more than ever if you do that. Now, you might have somebody else take the backups for you as part of your service agreement, but there needs to be backups. And the latest one, I've actually heard a customer say this, but we run our things on Docker. We don't need to take separate backups. It's like, okay, well, good luck with that. That's not how life works. It's, again, even more probably important than ever. So we need to take backups. And the problem is that backups are boring. They're particularly boring when they work. Actually, going out and seeing customer systems, helping them, trying to recover from the fact that they don't have backups, can be quite exciting. But it's not, a very productive work. When they're like, oh, we lost most of the database, can you try to find out whichever pieces can still be recovered because the last backup is 2 years old? Right? You don't want to do that. So backups are boring, but I'm glad you have them. Which is when we come to the second, when did you last restore them? If you haven't restored them recently, assume that you don't have them. I've run into at least 2 or 3 times with customers who actually did that test, right? They set up their backups, they ran the backups, they tested the restore, and they were like, this is awesome. And then they let it run. But it turned out on at least 2 occasions that it worked perfectly fine as long as you ran the backup only once. But when the cron job ran the backup, it didn't work. But they only tested it just after they set it up. And then, a year or 2 later, came there and, it didn't work. And it hadn't actually worked since the very first time they ran it. So test your regular backups. Don't make a separate backup to test it. Take your regular backups and try restoring those. Because, otherwise you can assume that the one time it breaks is when you really need it. Make sure it breaks when you don't need it. And have time to still fix it. Anyway, that's enough generic, because that's not really anything database specific, right? That goes for backups of your documents and anything, backups of your vacation pictures. But what about backups in Postgres? I'm sure many of you have been to, these Postgres events. You've been to presentations about here's how you do backups. You've read all those wonderful documentations, and then you've seen things like this. Like, oh, here's pgdump. You can run all these cool things. You can use, you should always use custom format if you use pgdump, by the way. That's very important. You can use compression, you can do it parallel, you can do data only, schema only, pick exactly which things you want, and pgdump is awesome in a lot of ways. But today, pgdump really is not a backup solution. It has many use cases, but backup isn't one of them, unless your database is really small. And even if your database is really small, it probably isn't the right solution anyway. But it's very simple. But it usually takes, for a lot of people, it ends up taking too long to do the backup. But that's usually okay. The real problem is it takes too long to restore. Because pgdump will recreate your tables, and then it will rebuild all your indexes and things. And if you're using a pgdump-based backup for some reason, make sure that you actually test it over time to realize how long your restore time is going to be. My current record is still a projected restore time of just about 2 months for a parallel PG restore. From a customer who thought, look, we have backups, we're fine. And look, you do have backups, but nobody's going to accept you saying, it's okay, we're restoring a backup, please come back in July. Right? That's not going to work. There's just too much overhead. And even on small databases, the problem is, of course, you cannot do point-in-time recovery. Now, sure, I actually have customers that run pgdump every 15 minutes, and it works because their database is tiny, and they go like, we have point-in-time recovery with a granularity of 15 minutes. And yeah, it works. There are exceptions, right? But it used to be 10 years ago in Postgres, like your default for setting up backups was, let's go to pgdump. That shouldn't be your default anymore, since a while back. Instead, if you're doing backups as your default method, you should be looking at doing physical backups. We separate them. pgdump is a logical backup. We do physical backups at the file system level. You can do this in Postgres. We use something called a base backup. And then you can do it with or without the log archive. Some of you will recognize the terminology. We'll look into a couple of them later. The biggest advantages are it's fast to restore, and it's that you can do point-in-time recovery. I mean, fast to restore is obviously still, if you're going to copy back 20 terabytes of data, it's still going to take a while, but it's not going to take 2 months, I hope. If it is, get a faster network. It has downsides like it can only back up everything. You can't back up an individual database or an individual table or something like that. And it tends to be, or it is platform specific. You can't take a dump or a backup on a 64-bit system and restore it on a 32-bit. You can't switch between big and little endian and those things. But that one in particular shouldn't be a problem for your backups. Because normally if you have a backup, you restore it back to similar hardware, similar operating systems. It's not supported to take your backup on Linux and restore it on Windows, for example. It works, but it's not supported. Or the other way around. You need to get all the compiler flags between the two instances to be the same. The easiest way to do that is, well, if you're using Red Hat, install the packages from Yum, and you're done. If you're using Debian, install the packages from apt, and you're done. And the next version will have, the next version of Debian will have Postgres built with the same parameters. They're also version specific, so you can't restore on a different version than you started. But again, for backups, the idea is something broke, you need to get back to where you were, then that's actually not a problem. So we do base backups, and I'm sure a lot of people who in here today is using physical backups on their databases in one form or another. Yeah, so that's most of you. That's good. And then you probably read the Postgres documentation, and again, all these awesome blog posts, and you've set up something like this. I mean, a slightly simplified version, but you do a set-e, you PSQL, you do select pg start backup, you tar it, and you PSQL, and you say pg stop backup, right? Who has got something that looks, approximately like this on their systems? No one? Yeah, you're just waiting for this one, right? There are so many ways to get this wrong. So just for curiosity, going back, anyone spot an error in this? Stephen?
Well, archive command, for one thing, you need your wall.
Yes, you need your archive command, but you don't need your archive command to get your base backup, to be honest. You need it separately, but yeah.
But you need to have it set.
You need to have an archive command set, but it doesn't need to be in the script. So, anyone else? Bruce?
You're not checking if PSQL work.
Well, I've got to set -e at the beginning of the script. So if PSQL fails, it's going to exit the script. Stephen?
Don't say .tar.gz, which is obnoxious.
That's a good point, but that's not actually an error. Well, then, there you go.
I think the F needs to come after the Z, too.
The F does not have to come after the Z since the past 15 years or so in GNU tar. But it used to be that way. But it also has what I would say actually the most common mistake I've seen, and because, as most Postgres consultants, you've seen very interesting versions of this script. There's the error checking will abort, right? So when the tar command fails at some point, it will abort, leaving your system in backup mode. And number one, the system, you will not be able to take another backup. Number two, you really don't want your system to crash now, because it's left things around in the data directory that will make your system not start if it crashes, right? So there are so many ways to get these wrongs that we should not do that. But this used to be the only way. And there are many, many, many scripts out there that people use that do this. And I would say the vast majority of them are broken one way or another. There are also packages out there that go like, here is a backup manager of different kinds for Postgres. And half of those are broken, at least half. Because it turns out this is actually very hard to get right. It was a crude interface at the time when this functionality was initially built. It made sense to have an interface like that. It doesn't really make sense anymore because it's too fragile. And we're trying to move away from it. We're trying to move away from it in two different ways. One of them is we're providing actually new versions of these low-level APIs in upcoming versions of Postgres. And the other thing that we've been doing for a few years is we're providing this tool called PG-based backup, which basically takes these base backups the same way, but instead of you running commands and then copying files in the file system and all that stuff, it runs just as a Postgres client. It uses the replication protocol, so the same thing as if you were running a standby server. And it's safe. And it deals with error handling and recovery, right? Sure, something can still go wrong, but it will then ensure that your database server is rolled back into a state where it's safe. It will not leave these files around. It will not make like, oh, your next backup is going to fail because your previous one failed. And all of those things are taken care of. And PG-based backup, I'd say today should be your main go-to for like, I need a simple Postgres backup that I don't need to make any setups for, that doesn't add a lot of complexity. If you're doing PG dump today, you should really look at just switching to PG-based backup. It's approximately as easy to get going as PG dump is, but that's it. It doesn't cover everything, right? And we'll go through a few important exceptions later, but it should be your starting point. So doing the same script, we just replace it. And we say this instead. We say PG-based backup, we give it a directory. Notice how I put tar in the directory name when it's not actually a tar. That's only to confuse Stephen. Actually, I did it to confuse somebody else, and I failed to confuse them at the time. The idea is PG-based backup with whatever you do. With FT, you say make it tar format, but it will still create a directory full of tar files. It'll create you a tar file for every table space that you have. And then we add the little magic parameter -x. I'll get into that in detail in a bit. Now, to make this work, you need to have replication enabled. This is something that we argue about once a year, whether we should have this enabled by default. So far, my side of that argument is losing, so it's not enabled by default. But we'll probably get there. My suggestion is, like, this should be one of the first things you do, like the first pass you do through your postgres.conf. While level equals hot standby. As of 9.6, that's while level equals replica. Means the same thing. And max while senders equals 5. Both those are changes that require you to restart the database, which is why I'm saying do them as soon as you set the system up. Like, the overhead is going to be worth it. Max while senders is the same as max connections, just for replication connections. Just give yourself a couple of them. You might need it for other things. Unless you use them, it's not that much. You want the while level this high so that you can do things like hot standby and point-in-time recovery and things. And set it up immediately. Then you need a special rule in your PG-HBA file. That's something like the one we have here, which is local replication Postgres peer. Just says the user Postgres is allowed to connect with a replication connection over the local Unix socket. Now, you don't need to change that one immediately because you can change PG-HBA with just a reload. But in order to be able to actually use PG-based backup, it needs to be enabled. If you're running PG-based backup locally, run it over the Unix socket. If you're running it remotely, put the IP address of your backup server in there. And use proper authentication, not peer. Whichever one, it's just a regular Postgres connection. So Any authentication method that's supported by Postgres will be supported by this. If you want to use passwords, you want to use certificates, you want to use Kerberos, it all just works. Now, PG base backup can write your backups in two different formats. It can use plain format, in which case you basically end up with your backup will be a copy that looks exactly like your data directory with all the subdirectories and all the files. But it's done in a safe way. So it will actually be a consistent data directory in the end, together with the transaction log, but it will get you there, which if you just copy the files, obviously that doesn't actually work. Plain works well if you have one table space. If you have multiple table spaces, by default, it'll have to write all the table spaces in the same location that they already are, which obviously only works if you're doing this across the network. Now, in recent versions, you can remap your table spaces to different locations, but it rapidly becomes very complicated if you have multiple table spaces to use the plain format. The other format for PG-based backup is tar, in which case the destination is still a directory, and we will put tar files into that directory. Your root table space will be in a file called base.tar, or if you're doing compression, it will be base.tar.gz. And then there will be one tar file for each table space. So in a lot of ways, that's easier for dealing with scenarios where you have more than one table space. Obviously, there are some drawbacks in this, which we'll get to in a moment. Now, in order to actually use one of these backups, in order to use a base backup, you need transaction log. Right? That's how these things work. In order to restore one of these backups, you need all the transaction log generated on your system from the beginning of the backup to the end of the backup. And what Postgres basically does, it takes an inconsistent copy of your data directory, and then it uses the transaction log to fix that. So if you don't have the transaction log, it's not getting fixed, and you don't have a valid backup. If you're using log archive, right, this is in your log archive. Right? That's the whole point of the log archive. But the fact is, with PG-based backup, you can also get it to include exactly these things that you need, from the beginning to the end of the backup, and put that in the base backup. My recommendation is that you always do this. Because if you do that, it makes your backup independently consistent. So if you lose your log archive, you can still restore your base backup because you have the transaction log required for that inside the base backup itself. Now, the downside is you may end up backing up this transaction log twice because you still have your log archive running. But that's okay. Right? That's the price we pay for getting independently consistent backups. And hopefully, you don't generate a huge amount of transaction log while your backup is running. So my recommendation, always use it even if you have a log archive, because it buys you a lot of safety and a lot of flexibility for the future. Now, you do this, there are two ways of doing it. You can use lower or uppercase X, which is the classic. We implemented lowercase x and then realized we needed to make it two options for it, so we then implemented uppercase X. We can include the xlog in two different ways. We can use what we call fetch mode and stream mode. Fetch mode is also the one you get if you use lowercase x, because that's the original implementation. And what PG-based backup basically does in this case is it takes the base backup. When it's done, it goes back and copies the transaction log as required. The problem with that is if your backup takes a long time, you probably know how Postgres works. You know, when you checkpoint, we eventually clear out your old transaction log. And if that happens before the base backup completes, the log isn't there anymore when PG-based backup needs it, at which point it fails. Now, unlike many of the scripts that people have written, it actually fails with an error code, so you will know that it failed. Now, if you don't check the error code, that's really your problem. You have to check the error code, but it will take care of that. It will let you know that it failed, but it still failed. Since that doesn't really work for large databases, the stream mode was created in, when did we do that? 9.2, I think, something like that. This one will open two connections. One connection for doing the base backup, and simultaneously it will open another connection to receive the transaction log as it happens. It actually becomes basically a replication standby and starts receiving data like that. This has much fewer failure scenarios. of course, if your backup taking machine is super highly loaded, particularly on the I/O side, it can actually still fall behind so far that your backup fails. But it's much less likely than with fetch mode. The biggest problem with it today is it doesn't work with tar. So if you're using base backup in tar mode, you have to use fetch mode. That will hopefully be fixed in the next version, so not 9.6, unfortunately, but in 10. We're hoping to have that one fixed. So pick one of them depending on that, but make sure you do one of these. Obviously, PG-based backup can also deal with compression. It uses standard gzip compression. The thing to remember if you do use that is that the compression is done by PG-based backup, not by Postgres. So if you run PG-based backup across the network to Postgres, the data will be sent uncompressed from Postgres to PG-based backup. Then it will be compressed and written to disk. Compression is only supported for tar format. It would be kind of weird if we individually gzipped every file in your data directory. The restore path from that would not be very nice. So that's the reason it only does it for tar. There are things to consider about it. This obviously, enable compression, you will become CPU bound. But the CPU bound will happen in PG-based backup. So if you run it on a different machine, that's where the CPU ends up being used. And you can run it wherever you want. Of course, the thing then people say, well, I want the data compressed between Postgres and PG-based backup. And the official answer for many years in Postgres has been, use SSL compression. Like, that used to be a bad idea. It is now a much, much, much worse idea. Because all the operating system distributions are going out of the way to make it difficult for you to enable this. Because particularly in HTTP, it can be a really big security problem. But the truth is, it can be a security problem in Postgres as well. And unfortunately, today, that's the only real answer we have for how to do compression. We need to fix that. Not just for the backups, but for replication traffic in general, for Postgres protocol in general. But I would say today, you really want to avoid going down the road of SSL compression, unless you really have no other choice. What you can get compression through is you can use SSH tunneling. Basically, the example here will, if you're in tar mode and set the destination directory to dash, PG-based backup will write a tar file to standard output. And then you can use, in this case, level 9 compression and just write it. There are other problems with this. It doesn't support -x anymore. It only supports tar format. Sorry, well, it supports xfetch. It doesn't support multiple table spaces. So it really, like, in fairness, we don't actually have a solution for transfer compression in the Postgres protocols. Yes, that needs to be fixed. Today we can't do that, and I would advise you don't go down the road of trying to get SSL compression to work unless you really, really, really have to, because it can be very fragile. And it can be a security problem. But once you have this set up and you remember to do the -x, you're basically done, right? You only need the one command in your cron file. They work. And they're reasonably safe. And once you are, again, PG-based backup with -x, you have reached the point where you can do everything that you could do with pgdump, but it'll be faster. Okay, so far, that's good, right? But that's usually not enough when we're really doing our backups, right? We want to do point-in-time recovery. For those of you who are not using it now, you want it, you just don't know it yet. The ability to restore to any given point in time and not just to whenever the dump or whenever PG-based backup ran. This takes a little bit more setup, but it's not that bad, actually. You need to set up an archive command using log archiving, where basically Postgres will take your transaction log and send it somewhere as soon as it's done. And you'll have an archive command that looks something like this. I think this is copied directly out of the Postgres documentation, right? So test if the file doesn't exist. It's mounted on NFS somewhere, and then do a copy, and something like that. I mean, most of you, everyone's seen an archive command that looks something like this, I assume? Yeah, don't do that. It's kind of sad that this example is in our documentation because, again, there are so many things that are wrong with this command. It works fine as long as everything works, right? But the whole point of your backups in your log archive is to work when things don't work. So don't set up something like that. The way that we set this up in the modern way using the built-in Postgres tools is using a tool called pgreceive xlog, which you run it on your archive server. Because don't archive to the same machine that your database is on, by the way, regardless of how you do it. Because if you lose that, you lose both your backups and your primaries. And what you basically run this thing on your archive server, it connects to Postgres over the replication protocol, and it's basically a Postgres replication standby without Postgres. And it regenerates the log archive based on the replication data on your archive server. This gives you a number of advantages. It gives you a more granular recovery. With an archive command, data gets sent in block of 16 megabytes. With pgreceive xlog, they get sent in blocks of 1 byte, or however big the chunks that are being written are. It is safe against server restarts. Weird things can happen if your server reboots in the middle of running your archive command. Like your CP command is running, but it didn't finish, and then the server rebooted or something. Weird stuff can happen. pgreceive xlog will take care of that. It can follow timeline switches on the master. It can do a lot of these things. And it's very easy to get up and running. A lot easier than actually setting up your archive command in the correct way. As of 9.4, you should always use pgreceive xlog together with a replication slot. This only works from 9.4 and up, but that's why I put modern in my title, right? If you're using anything older than 9.4, you're not modern. pgreceive xlog works since 9.1. With a replication slot, the thing is, otherwise pgreceive xlog can, just like a replica, fall behind so far that it can no longer recover because the transaction log was rotated on the master. The downside of a replication slot is that if your pgreceive xlog stops working, your master will run out of disk space. But that's actually a feature, right? We don't delete data. If your backups stop working, you have to make a decision saying, I know that my backups don't work, and kill the replication slot, and then it'll start recovering disk space. But unless you tell the system that I'm okay that my backups don't work, Postgres will keep your backups working and then run out of disk space and shut down, because the primary job is to protect your data. So yeah, it's not the actual shutting down that's the feature. It's protecting your data that's the feature. Setting up pgreceive xlog, very simple. You say pgreceive xlog, you give it a directory. That is your log archive. You tell it where to connect to, which should always be over the network. And then you give it the name of the replication slot that you have created by running pgreceive xlog create slot. And don't forget to make sure that it's restarted. Because if you get like a network error or something, pgreceive xlog will exit. And you should restart it. And then it will figure out where it is in the stream. It'll reconnect, and it'll catch up itself. But if you don't actually restart it, that's not working. pgreceive xlog is pull, not push, so it needs to be running. But there are easy ways to make sure that services are automatically restarted if they fail. Just don't forget about it. And once you have that done, you actually have all the things that you need for point-in-time recovery of these reasonably simple databases. And it's not very hard to set up. Of course, the next question that people end up asking is, well, what about backup retention? How long am I going to keep my backups around? Some of us are working with regulatory requirements that say you have to keep your backups around for 10 years. That's fine, but if you go back 10 years, do you still need microsecond resolution on your backups? Or maybe you only need like yearly resolution that far back? Probably not microsecond, at least. And then you ask the question to the business people, and they will go like, you mean you could provide microsecond? And then you tell them what it would cost them. And now they don't want it anymore. But you might want microsecond, for a few weeks, and then, granularity getting lower. Now, to recover one of these backups, you need the base backup, and you need all the xlog from the start of the backup to the end of the backup, and then you need all the xlog from the end of the backup to the point that you want to make the recovery to. And the thing that you need to restore anything at all are the first parts here, the base backup and the xlog from start to end. That's why we use -x, right? If you use -x on PG base backup, these things is exactly what gets stuck in the base backup. And that's how it becomes independently consistent. Then you can use that and still connect it to your log archive if your log archive isn't broken, and then you will be able to also do point-in-time recovery. But exactly how many generations of everything you keep around, it's really going to depend on your business requirements. One thing that I've also found that simple backup retention, as long as you're using -x, becomes very, very simple. It's usually enough to just use the find command. And delete all the logs older than a certain time. That means that once you go past that time, you lose point-in-time recovery. But since you made your backups with -x, you can still recover those backups individually. So in this example here, let's see what we're doing. We're deleting all our base backups older than 30 days. So we're saying if it's older than 30 days, you don't get to restore the backups. Okay, maybe that's not the best thing ever. You might want to keep some backups older than that. Maybe you're staging them to tape or whatever. And then we're saying delete all the transaction log in the archive older than 7 days. So what that means is going back 1 week, you can restore, using point-in-time recovery, to an individual transaction or microsecond level. Beyond that, you can restore, well, assuming you took a base backup every day, beyond that you can restore with the granularity of 1 day, up to 30 days. And once you've reached that point, well, you can't restore anymore. But simple policies like this will, for many, many deployments, be just enough. And it's very simple to set up, and very simple to use. Now, if that's not enough, this handles the simple cases, right? It has limitations. It has limitations particularly in management. It has some limitations in performance. But it's simple, and it's easy to get right. And in particular, it's very visible when you get it wrong. So it handles a lot of things. But there are other tools out there that will help you sort of take this to the next level. Now, someone said, I can't remember who it was, so the person might well be in this room, and said every Postgres consultancy company eventually reaches the point of writing their own backup manager for Postgres. It wasn't, someone said it, but if you actually look around the different Postgres consultancy companies, it's pretty true. Most of them have at one point gone there, so there are plenty of these tools out there. The sad thing is some of these tools that were written a few years ago are actually doing the wrong thing. And these tools were written by the people who were supposed to know. That's how complicated it was. Today, I'd say if you're looking at there are also things that will plug into your big, expensive enterprise backup solution thingies. I'm not going to talk about those. You've got salespeople to talk about those. But if you're looking for things in the open source space, in the community space, today there are two major tools that are out there today that you should be looking at. These are Barman and PG Backrest. I would say mostly today the other tools that are out there, sure, if you have them set up and they're working, double check that they're actually working, because they might be looking like they're working, but they're getting some of these tiny details wrong. And then they will work 99 times out of 100, but they will not work the one time you need it. But if you're looking at something new to get you to deal with things that are a little bit more advanced than what PG Base Backup can do, these are your two main tools to look at today. And just starting in no particular order, alphabetical order, Barman, it supports a lot of features. It supports backup scheduling for you, log archiving, it'll manage your log archive for you. It does retention management. It does multi-server backups, so you have one Barman installation that pulls in from multiple different Postgres versions. It has some nice restore shortcuts, because while Postgres has these PG base backup and PG receive xlog to take backups, it actually has no tools to help you restore them. You're on your own with that. But these are sort of some of the basic features that you'll get with Barman. Barman is built by Second Quadrant, one of the sponsors of this conference, and I'm sure you've seen them around in the Postgres world a lot. It's written in Python, if you care about that. Personally, I'd like not to have to care what my backup software is written in, because I like it to just work. I don't want to have to patch it. It's GPL v3. It is primarily uses SSH and rsync to transfer both base backups and transaction log. 1.6, which was out earlier this year, actually just learned about using PG receive xlog to build the log archive. So you can use that. It will still use SSH and rsync to do the base backups. So it does not have the ability to use PG base backup as an option. I think they're working on it, but it's not there yet. Yes? Does that also mean that it's not fsync? Not by definition. You can still run fsyncs. and I think they do that now. They didn't used to do that. It also means that you need to set up SSH keys and user accounts between your machines. It also means that if you're running Windows, I'm sorry, that's really, really hard. You can get that to work on Windows, but it's really hard and it's really ugly. And it's really not meant for that. They also don't safely support concurrent backups. There is an option in Barman to support concurrent backups, and I would strongly advise you not to use it, because it's really dangerous. It requires you to install an extension on the server that's very unsafe. As long as everything is working properly, it's fine, but it's fragile. Why would you need concurrent backups? Is to be like, why do I care about that? Well, particularly because this is the same thing. You also can't take a backup the same time as you're provisioning a new replica, for example. So there are use cases for doing that. So those are a few short things about Barman. Said the other option we have is PG Backrest. If you're interested in PG Backrest, jump in your TARDIS. There was a talk about it yesterday. Go back and see it there. PG Backrest support things like backup scheduling, manages your log archive, does retention management, multi-server support, so you can have one Backrest server handling multiple Postgres servers. It has helps for the restores. You'll notice this is a fairly similar list of features to Barman. These tools are solving the same problem. So the feature list is similar. Once you get into the detail, the implementations are different. But the basic feature lists are in there. PG Backrest is built by Crunchy Data, which is another sponsor of this conference, which is awesome. It's written in Perl, so if you hate Python and love Perl, maybe you want Backrest. If you hate Perl and love Python, maybe you want Barman. If the language makes you choose your backup, then really get somebody else to choose your backup software for you, because that should not be how you choose your backup software. It's MIT licensed. It uses SSH, but it doesn't use rsync. It uses its own protocol tunneled over SSH, which is, I think, the main feature that Backrest has, or the protocol is the enabler of the features that Backrest has that Barman doesn't. In particular, it supports parallel backup sessions, so you can scale out and make your backups run faster. For most people, single-threaded backups is not really a problem, but if your database is big, being able to do multi-threaded backups can save your backup time significantly. And also, obviously, your restore time when you're getting things back, which is more important. It also supports full differential and incremental backups. And it does this at a segment basis. So in Postgres, we have all our tables are split into segments of 1 gigabyte. And Backrest basically goes, if this block here of 1 gigabyte, if nothing here has been modified, then I don't need to back it up again. If even a single byte has been modified, it'll copy the whole segment. Because if you want to do it by scanning the way that Backrest does sort of after the fact, if you actually want to look at every block, it'll just take too long to figure out if something has changed. But doing it at a gigabyte, it means if large portions of your database is read-only, your backups will be much faster because we can just skip that and get it from the previous full or differential or something like that. So Backrest has a couple of things there that Barman doesn't. Backrest currently does not have support for pgreceive xlog. It's being worked on, at least there's a ticket on it. So you're still stuck with the granularity of 16 megabytes into your log archive. Now, if you have a standby server, that's probably not a problem, because if you're recovering from a hardware crash, you can go to your standby server. But if you don't have that, you get worse granularity on that. It does not support concurrent backups.
Well, let me just mention, you can run a PG-based backup concurrently with a Backrest backup.
So that's a good point. It does. You can run PG Backrest or Barman, doing one backup, and then a PG-based backup concurrently with it. But you can't run 2 Backrest backups concurrently or 2 Barman backups concurrently. I was going to say, this is one of the things that these new APIs in 9.6 are there to help you fix. And yeah, I know, does Backrest have the feature now?
It has it for 9.6.
It has it, well, yeah, for 9.6. So it has it for 9.6. Last time we talked about it, so David here is the main developer of PG Backrest. Last time we talked about it, you were working on it.
Yes.
So it will be there for 9.6. But you might, well, 9.6 is release candidate. You can just go to that now. So these are things being worked on, and both these tools are being actively developed, right? Which is a lot of the other tools that other consultancy companies have come up with before, or people, many of them are just not being maintained anymore. They still work. If they were safe then, they're still safe now. But a lot of them are sort of borderline in some ways. So that's why I say, go look at these tools as your primary choices. So let's go for a quick summary. The most important takeaway, if you're doing backups in Postgres today, don't roll your own. There are just too many ways to break that. And that goes for both base backups and log archiving. Right? If you know exactly what you're doing, sure, do it. But you probably don't. Leave that to these people who are spending a lot of time building these tools and running into these issues and going like, oh, that's how it worked. These are complicated things, and your backups are too important. Right? If you have a corner case that only fails 1 in 1,000 times, that's still too bad for your backups. Because you know when you're going to need the backups, right? It is that one time. That's just how it works. Which is also why your primary choice today, if you're doing backups in Postgres and just like, hey, I need to do backups, you should use the built-in ones. You should use PG-based backup, and you should use PG-receive xlog if that's enough. If that solves your problem, if your database is not too big to handle that, if your retention requirements aren't too complicated, then just use that. Because it's simple to get working, it's difficult to get wrong. And that's a good combination. If you can't do that, your secondary choice, go use Backrest or go use Barman. Look through their feature lists, figure out which one matches your requirements. They each have their different strong points. If your point is, my database is 40 terabytes, I need my backups to be fast, go to Backrest because they support parallel backups. Stephen.
I just want to point out, you mentioned transfer compression being a problem with the built-in tools, but you didn't mention that Backrest has transfer.
That's a good point. Backrest and Barman both have transfer compression. So you can do it in both of them.
Backrest also has destination compression.
Yeah. So yeah, they solve a lot of these problems that aren't currently solved by the built-in one. The price you pay for that is a bit more complexity. You need to get your SSH keys and all that stuff set up, but once you have that set up, it tends to just work. And if your primary choice, if that's not good enough, and the secondary choice, if that's not good enough, then restart from the top of the slide and change your requirements. You should really, if you go oh, I have this one requirement that none of these things fix for me. Well, number one, maybe you should go talk to the Backrest or Barman people and say, hey, here's an actual problem that I have. What can we do to fix that? This is an open source community. They will be happy to talk to you. They will be happy to take your submission if you know it well enough that you can write the patch for it. Or you'll find someone to help you build the code for it. But do that rather than trying to build your own. It's really hard to argue today, I personally think, for the right thing is to build my own. Just avoid that as much as you can. Now, granted, when I gave this talk in St. Petersburg this summer, someone puts a hand in the back and goes hi, we're Yandex, and we have some other requirements. And yeah, they have extreme requirements, right? So they're building their own page-level backup thing. I wouldn't recommend that any of you do that, again, until you have exhausted all the other options. So stick to these built-in, Backrest or Barman, change your requirements. That's the order that I'd say. That's all I had. I think I have about 5 minutes for questions. So any questions? Yes? What do you think about Wally? Wally's pretty good. Wally is good if what you're doing is Amazon. If you want your backups to be on S3. Does Backrest do backups to S3? No. Okay, and Barman doesn't. So basically, if you want your backups to be on S3 or S3 compatible services, then yes, Wally. If not, then no, not Wally. But that's but that is a good point, yes. Wally is good if you're doing your backups on Amazon, basically, which is not entirely uncommon. Bruce?
When you're running archive command and fails, you get a message from Superlog right away. When PG receive xlog fails, how do you report it?
So the question is, when you're using your archive command, if it fails, you get a message in the system log immediately. What happens if PG receive xlog fails? Well, you get a message in PG receive xlog. It's a different log. It's not in the Postgres log, it'll be on your archive server, but yeah, you have to monitor the log on your PG-receive xlog side to make sure that it's still running. And you can also monitor, it'll show up in pgstat replication. So you can look at it and see if it's falling behind or like how far behind it is. So you don't need to look at the log files. You can monitor it from inside the system as well, but you absolutely need to monitor it, yes. Yes?
Is it possible to restart PG-receive xlog on just a cron job if it's already running?
Is it possible to restart PG-receive xlog in a cron job and like have it kill itself or not start if it's already running? Not built into it. Like you can write your cron job, do a PS to check if it's running and then kill it, or put it under an init system that will just do that for you. As those of you who work with me on PG Infra know, I'm not a huge fan of systemd, but that's one of the things that systemd actually does well. You set the parameter in the unit file and it'll just restart it for you. And you say, sleep 10 seconds and then restart, and that just works. Put it in a shell script with a loop. Like, it's not that hard to make sure that it gets restarted. You just have to remember to do it. Okay. Anyone else? Yes? So the question is, does PG Barman or PG Backrest support encryption? You mean encryption of the stored backups somewhere? I don't believe that they do. In themselves, you can take them to an encrypted container, like an encrypted loopback device or something like this on your operating system, because what they're dealing with is just files, but they don't natively support encrypting, like piping things through GPG or something like that. Stephen?
So encryption is something that we've been discussing adding support for. So if you're interested in it, certainly talk to us.
Yeah, I think that is the reason I'm looking at PG4. That's another backup that is pretty interesting. It's using PG-based backup as well as PG-receive xlog. It's called PG-Hold.
Yep. Yeah, there are other tools out there. The PG Hoard is the one you're referring to there. That one only drives PG-based backup and PG-receive xlog, but it has a few other things onto it. So yeah, there are other ones out there. There are other ways of doing it. So these are solvable. Yes?
It seems to me that talking about the stack utilities, they seem relatively complex. I'm going to lump replication into backup. There's a lot of conflicting options and configuration that tries out to do. So do you think that the current strategy is going to stand, or is there going to be some kind of simplification of all the options?
So the question is, today setting up both replication and backup on the server side and the built-in ones is pretty complicated. There are many different options and things like that. So do we think that is changing? I think we're probably going to be keeping these options. I'm very much hoping that we're going to change the defaults so that most of you will, like if all you want to do is backups and maybe set up one standby server or something, you shouldn't need to change anything. It should just work. But please join in the next time we have that argument on the mailing list that, yes, we should have those defaults. I think that's one of those things that I think most of us who actually spend a lot of time talking to many different customers would like to see the defaults changed. And people who are building Postgres and running very specialized deployments don't care for it. So we'll see. I hope we get there. Okay, anyone else? Okay, in that case, thank you very much.